Okay, so question number 4 asks to draw the Lewis structure for arsenic pentafluoride. Okay, so when we draw Lewis structures, I first want to find out my total number of valence electrons in the molecule. In the case of arsenic, it has 5 valence electrons, and in the case of fluorine, there are 7 valence electrons. So our molecule is arsenic pentafluoride. So I need to multiply this by 5. And then, so 35 plus 5 is 40 valence electrons in total. Now it sounds like a lot, but once you actually draw it, so let's draw arsenic in the middle as our central atom. And then all of the fluorine atoms around it. Try to make it symmetric. And each has a single bond to arsenic. So each bond contains 2 electrons. So far I've drawn 10 electrons out of the 40. So now I'm just going to draw all the lone pairs on my fluorine atoms. So each fluorine has 3 lone pairs, or 6 in total. Okay, so now I have drawn out all the lone pairs on my fluorines. And now let's see if we have 40 electrons drawn in the structure. So again, each bond contains 2 electrons, so I count out 5 bonds, so that's 10. So I need 30 more, but each fluorine contains 6 electrons that are in the form of valence pairs. And there are 5, so 6 times 5 is 30, so I have reached my 40 electron count, and I don't need to draw anymore. So this is the final Lewis structure for arsenic pentafluoride. And the junior tutor said to first determine the total number of valence electrons. The arsenic atom in group 15 has 5 valence electrons, and the fluorine atoms in group 17 have 7 electrons each. Total number of valence electrons is 40. Second, write a plausible skeletal structure by joining atoms through single covalent bonds. Okay. And then third, subtract 2 electrons for each bond in the skeletal structure. The 5 bonds in this structure account for 10 of the 40 valence electrons. This leaves 30 valence electrons to be assigned. So lastly, complete octets for the terminal fluorine atoms. Yep. So great step-by-step answer. So this solution is correct.